RMAG, Rocky Mountain AI Interest Group, we had it was, first of all, packed out. It was sold out within, I want to say, 3 days of our saying. And by sold out, that's like 150 at the CU Boulder campus. And we had, I think, at the top, like 90 on the waiting list. And then a lot of people, I'm sure, on the waiting list still showed up because there were people like crouching in the aisles. It was crazy. It was nuts. And it was pretty cool. We had Kamiwaza, a Colorado AI company. Right after the talk, they just announced that they closed an 11 million round, or back-to-back rounds, actually. And
then at a different event that happens at the Google campus that also was significantly over reserved, they had a whole bunch of hiring, so they're doing all right.
Yep. And so it's been, and then so that Tosi's point, yeah, that's that big basically dev jam at Google Boulder's offices. And then we're in February, and we were already talking about how those percolating topics, Kamiwaza, they're doing a lot with agents from like a bottom up perspective, but how those percolating topics are going to change AI in 2025, DeepSeek lands, boom. And then, like from an engineer, I'm like, oh, finally, all this stuff that I expected was going to be happening in AI. I mean, I don't pretend I had a crystal ball or anything, but I was a little shocked at how people were shocked that, hey, engineers can actually do stuff here, and do stuff that'll blow everyone's mind. So yeah, it's been quite a year. We're 1 week into February, not quite, and so much to talk about.
Yeah, I've been so impressed with how the Boulder, Denver, Colorado AI community is just like continuing to compound on itself. In 2 years of being here, being able to plug in with people building, people running companies. I mean, I can't speak highly enough of Rocky Mountain AI Interest Group. I think everybody talks about how hot San Francisco is, but I would argue it's easy to jump into Colorado and get plugged into like really high quality engineers and entrepreneurs very quickly. We're all, I think, very long on Colorado for that purpose.
Yeah, absolutely. It's been great. Like at the meeting, it was interesting because I put up, I asked at like a scene setting questions, like how many engineers are here? And it was about, I want to say 60% of the room. Now there's a downside to that because I think everyone giving a talk, I had actually said, let's really balance it between engineering and business. And I think everyone said, oh, we got to skew hard towards the engineering side. And maybe left a few of the, business audience members like, what is going on? But it's just interesting just how many people are really out there rolling up their sleeves and doing stuff with AI. I'm also, I go regularly to the Rocky Mountain AI Interest Group Engineering subgroup, and that's become, really, really, lots of people showing off projects and cool stuff. In our startup subgroup that I run, AI for Startups, lots of people showing off, what they're doing with like Lovable and, V0 and other stuff like that to accelerate, software development for their startups. So yeah, so much going on.
Right. And like, shout out to like Bobby Hodgkinson and like, RMAG and education subgroup is super interesting. They're putting out some interesting content. And then also like Robert Monaco with the AI ethics subgroup as well. Like shout out those two folks. Like, honestly, they're pushing really interesting topics, and there's now like 12 RMAX subgroups across
we
Denver,
just
Boulder.
Yeah. So actually the 11th or the 12th one just got is going to kick off very soon. AI and product is going to, come back. So yeah, it's in fact because I'm on the board of RMAG as well. And one of our big topics is what's our criteria? Are we going to end up with like 25 subgroups? Because there's so much, people want subgroups in research, people want subgroups in, different geographic locations, all sorts of things. So it's like, how many of these are we going to have? So,
right. That's an awesome problem to have.
Exactly. And we're like,
it's not like you have 25 people with 25 groups,
Well, yeah, exactly. It's not distributed that way. I think a lot of the groups are really, thriving. I know like the Denver AI group, they pull like 80 people to most of their meetings now. We did a workshop on hands-on, basically introduction to AI DIY, basically getting your hands dirty with AI. And we had, I want to say, well, okay, we had 5 groups of 6, so about 30 people. Yeah, so all trying to come in and learn how to do AI stuff.
There was 8 people on most of those. I think it was closer to 40.
Right.
That's awesome.
So yeah, OC led that one. It's just, we're just helping people basically basics such as here's how you set up a vector database. Here's how you set up an LLM on your laptops. You can experiment yourself. You don't have to leave it to, the big names out there. Sam Altman doesn't get all the fun, and Mark Zuck. So.
Right. Then we just need to throw a big ass party at the end of the year. That's what I'm hearing.
Yeah,
very fun
for sure. But yeah, I mean, it's interesting because Wikami was, of course, being a main topic for that agents discussion in January, and then announcing the big raise. And so what they showed was basically what they do with agents, but they also brought in somebody from, I forgot which of some government department that, and they're using AI basically to assay data basically, and to analyze large amounts of, was it weather data?
They were pulling from a lot of NOAA data. Yeah.
Yeah. So it was NOAA, National Oceanic Atmospheric Observatory, et cetera. So yeah. And doing all sorts of, and basically automating, saying, I need to figure out XYZ with the data. And of course it goes in and figures out the spreadsheets and writes the code and runs the code and all that sort of stuff that, this woman who she's a data scientist, not really a developer, but she's like, yeah, I had this thing writing all this cool code and developing all this stuff and coming back to me when it got stuck. And so, it was fun to watch that. And then, of course,
just kind of funny that wraps around a data scientist gets heavy use out of an AI.
Yeah.
Yeah.
And which leads me to DeepSeek, because then DeepSeek comes along and it's like kind of like, I can't believe like stock market market caps falling by $1 trillion aggregates. I'm just like, what is going on? Is that really what the marketplace was expecting from Gen AI, that it was really going to be this exclusive billionaires club, for more than another few months? They haven't been paying attention to what's happening in the open source world in that case, or what's happening in China or in France with Mistral. I mean,
right. It's almost funny because it's like the Nvidia stock dropped, but it's like the DeepSeek used Nvidia to train it. Like they're going to need more Nvidias.
Yeah.
I think it kind of like, to me, it's just like they were looking for something to spook them in the market.
Yes, exactly. It's clear from the reaction that they were looking for something to spook them, and this was coming. I mean, someone made I read somewhere the perspective that even after it dropped, Nvidia's, PE ratio is still at like 100. It's just like, how?
Yeah, they're still going to be good. Yeah.
I'm again in it.
I wonder if like they preempted that by like launching DeepSeek when they knew Trump was going to come into office, because they knew he was going to impose tariffs, and this is like a covert way to like tank our market.
40 chess,
right? I think maybe, but I also think it could be as simple as the hedge fund that, which is a very important detail. A hedge fund owns DeepSeek, right. DeepSeek, parent company. Wouldn't be shocked if they were just shorting Nvidia. that could be rationale alone for this.
Yeah, well, hopefully they don't, have a big fall. But yeah, no, it's really cool because it's just really cool because, of course, DeepSeek, to me, as as an engineer, and I'm not a data scientist, right? I'm definitely an engineer, old school engineer. LLM ops is my baby, like I think all of us on the call. And I'm all about, okay, this is really cool how you do it. How are we going to apply it to projects? And like when DPO came out, direct preference optimization as a way to train to fine tune large language models with, very, very straightforwardly. It used to be, with PPO and all the other methods, you would have to have like, competing model. You sometimes have like 3 separate AI models involved in that process. DPO comes along and is basically, just get a few examples of data and, one sort of tutor model and you're good to go. And so I'm like, oh, okay, we're getting to the point where you can actually use this to make LLMs suitable to solve specific business problems. And I'm just thinking, you know what? They're just going to keep on improving on that and improving on that and improving on that. I mean, PPO, to DPO, we're talking like 2 years or something like that. DPO to GRPO, which came out with DeepSeek, about a year. It's just the way it's going, right? And so GRPO, of course, which is, I think, the big, from an engineering perspective, the big new thing, that the breakthrough, I should try and say, in DeepSeek, the ability to, in effect, make models so much smarter, so much quicker, with the knowledge you can apply to
more efficiently, cheaper.
Yeah, it's exciting, and exciting that it's open source, and that the approach. So I've been also getting involved in like bringing GRPO to the Apple Silicon MLX library, which is basically machine learning inference for Apple Silicon.
If you don't want to use Nvidia.
Yeah, exactly. If you don't want to use Nvidia,
other option.
I've been shorting Nvidia. I'm like, you know what? I've never liked energy stocks, so Nvidia.
Yeah,
I like Apple Silicon, which sips the power instead of gulps it.
Yeah.
Right. Do you guys see like a different, or Uche, do you see like a differentiation in I feel like with DeepSeek, like they trained it to be like, it's a lot cheaper and it runs on like a lot cheaper hardware. And I feel like there's going to be a lot of models, like especially after this next wave of GPUs come, and then there's going to be another wave, and just constantly, I feel like the price is going to drop on the current ones to where there's going to be a lot of models trained in these types of ways. And I feel like that just shows that like the price of AI is like going to zero, except there will always be a high end of like these reasoning models aimed at like scientific math, like harder problems. But I feel like the bulk of the intelligence, the cost is going not to zero, but like the cost of running an EC2 server, basically.
Yeah, it's crazy how the cost for inference will go down. The cost is going down. The cost for training is going down. And then the cost for algorithmic innovation is going down too, because it used to be that to discover something like the attention mechanism way back when Google first discovered it, you needed to have all the TPUs out the wazoo. Basically, it's what they.
I think it's also worth noting that from a hardware perspective, while the new Nvidia hardware is impressive-ish, it's still running on the same old hardware nodes that they had been running. It's mostly a better configuration of that hardware, of the actual silicon itself, to do stuff like have better memory bandwidth than it is some sort of like fundamental, like we packed more transistors into it kind of deal. It's a software efficiency improvement, not necessarily a hardware efficiency improvement.
So, I'm sort of curious, because I do want to come back to DeepSeek, but are any of you guys like looking to experiment with like the new Jetson stuff coming out, the Nvidia specialized inferencing boards and machines?
I can't say that I'm going to experiment with it, but I do follow the space closely to try to see what's going to happen. I follow it like probably a little bit more at a business level than I should. But like, so like, what is that?
What's been going on there?
Like, what is that?
Yeah. So I guess the way that I like to think about it, for everyone, watching, is that I always make the joke that gamers invented AI, because, they drove the price of GPUs. It's like back to the, old school gray beard engineering. It's like, I remember when, was that back in the 80s when everyone was like, we don't need floating point operations, dummies. Everything's integer. It's all integer, right? We got VisiCalcs out with spreadsheets. It's all integer. Everything we need is integer. What do we need floating point for, right? It's like only those crazy geeks, trying to do, what was that asteroid game that at the MIT computer or stuff like that. And then, of course, the wars came out with OpenGL and, Microsoft DirectX and stuff like that. And then, Nvidia and Intel and everybody being like, oh no, we need floating point, for polygon, raster, for shading, for all this stuff. Yeah. And then all of a sudden someone says, we can do AI models with this, right? And so they built it. But of course, I think we finally got to the point where it's like, okay, we got to outgrow the whole gaming part of it. We're going to focus just on pure, inference, AI inference iron. And that's what the Jetsons are. So the Jetsons are just kind of like that same ability, which makes it possible to do AI with like a 4090 GPU or something like that. But take out the unnecessary stuff and just have the AI piece in it. And they announced.
I think that makes, to me, like Nvidia is kind of a result of like, if you think about it, like TSMC makes like 85% of the chips. They've basically commoditized that. It feels like they just had a lot of time booked on the assembly line there. Gaming growth that never came. And they were like, oh my God, we found the best market ever. And they're still pushing basically their gaming GPUs, and they haven't like really focused on making it for the workloads.
Yeah, and when that's a good point, because when they announced the new line of Jetsons, I forgot the code name they gave some cute code name, but they announced in December, and they sold out almost immediately. And you're just kind of thinking, okay, I know there would have been a lot of interest, but they must not have had a lot of capacity, to build those. And I know that Thor, okay, and I know that like they have like new batches that are supposed to be coming out any moment, because I do know a couple people who've been interested in it. It's just interesting because you can, once those things start getting into people's hands, it's going to get harder and harder to put the genie back in the bottle for anybody who thought there's this magic moat, in Gen
No, I mean, I think that they're just trying to preserve the moat by buying all the GPUs.
They have
which is a strategy if you're getting 500 billion from the government,
Yeah, that's true.
They have like the workhorse level GPUs, like the RTX 9080s and stuff. Those are probably pretty good for it too, other than like gaming GPUs.
Yeah. Yeah, but I mean, so like I said, I was asking if you guys experimented with it much, just because I really am, and I think OC is, but I won't speak for him. So sold on like Apple Silicon, etc. And again, not because I'm definitely not an Apple fanboy. I do happen to have a MacBook Pro, but my phone is Android, people.
Yeah, I think we are the most hating Apple MacBook user I'll ever meet.
But the reality is, again, I'm an engineer. I recognize good engineering. And, they've got this stuff doing the same level of inference for literally 50, 60 times less energy draw. I can
although that is compared to to your point, that is compared to the full fat gaming GPUs,
that's true,
where it's using,
the Jetsons are
very wasteful. The like for like comparison of Apple Silicon versus the Jetson, or Apple Silicon's NPUs in particular versus the Jetson chips.
I've still seen
it's still better.
20, but not, you're right, not quite as bad as like what a 4090.
Yeah, 4090 or
I feel like that's all. Are you guys just talking about running it on like a normal like MacBook or like even like the heavier ones?
Yeah, so the DeepSeek's getting run. I've seen several posts of people running even the full size,
the full 671,
full 600 billion parameter on just like a desk full, like literally stacked Mac Studios and Mac Minis.
Mac Minis,
which is so funny to see, like a LLM to rival OpenAI's most powerful models that would require literally hundreds of times the physical volume to run
equipment,
on a desk.
Are they ahead on that because their chips were so like graphical intensive before?
So I missed the beginning of the question.
Like, why is Apple ahead on this? Do you think they just got like better engineering with these chips, or like do you think that they have the expertise in house because they were shipping Max Minis for graphical things for a very long time?
I think Apple has. It's been a long time. It hasn't. It's been pre-AI that Apple has really focused on reducing power draw in the MacBook Pros.
Yeah.
But
that being said, I actually think that, and again, this is a very weird thing to say about Apple, but I genuinely think that a lot of the difference that's being made is the fact that Apple's been really open with the architecture, and letting people like Uche, who have no financial tie to Apple, still do important development work and get that out there. One of NVIDIA's big moats right now, in fact, probably the big moat is CUDA. And people have been trying to get AMD GPUs, for example, to run CUDA for a while. And even AMD doesn't seem to be super interested in it if you follow stuff like Zluda, which is kind of infuriating, because it's like no one's going to be, you can pack all the horsepower you want into the GPU. If the APIs which programs actually run on can't use all of that horsepower, none of it matters. And that's the difference that I think Apple has been making. They made it so that you can use all of that graphics horsepower for something that isn't in fact graphics in this specific case.
I think there's also a bit of an original sin here. Sorry, and I'm doing a lot of like going back to geek roots and geek engineering roots and stuff like that. But hopefully people will appreciate.
Keep it going.
Hopefully people will appreciate that, because I see a lot of very shallow takes in this whole DeepSeek conversation, which is part of why I'm excited to get the AI DIY crew back together. But,
I'm looking for a deeper take.
Exactly. But I think there's an original sin when Intel won, because I still remember like Intel versus Motorola, and Motorola is like reduced instruction set computing, right? We're going to simplify everything. We're going to decompose the problems, use fewer registers on the chip. simplify the chips undergoing microcode versus Intel, which is kind of like, we're going to put a computer within our microprocessor, which runs your computer, with complex instruction set computing. And the thing about complex instruction set computing is, in some ways, it's easier for like developers, to work on. So Intel was.
I just throw my problem at the cores that are specifically designed to solve this problem, and I don't have to think about implementation or anything like that.
And that's how I think we spiraled into the whole realm of, we don't care about energy, efficiency. We don't care about memory efficiency. We don't care about compute efficiency. Everything is just, basically shovel approach to software. And that's been the case since early 90s, right? And Nvidia, they just followed the trends, right? So Nvidia's approach, CUDA and all that, it's more akin to, I don't want to go too deep, but it's more akin to complex instruction set computing than reduced instruction set computing. And that's one reason why Apple. So the whole thing about M1 Silicon is they're using ARM chips. ARMs are the revenge of reduced instruction set computing. They're a reduced instruction set computing chip, which is finally coming to the fore when the more you're trying to put a chip with the power to drive, an iPhone or an Android phone, guess what? You can't put a freaking, Intel chip in it. Your phone will burn a hole in your pocket. So, reduced instruction set computing made a comeback. And then Apple.
And I think that's really critical. A lot of people boil down power problems to just electricity supply. But even if you manage to have magical batteries in this specific example, magical batteries that could power these chips inside of a phone, you still have a literal, just thermodynamics, really, really fundamental engineering problem of where does that heat actually go. I recently built a new gaming computer and I have no idea what the hell I'm going to do over the summer because it pulls more than 800 watts at the wall. I can't use my old UPS anymore. Like
I was watching I want to say it was like the Lex Friedman podcast or something, but they like threw up like a data center, like a Google Maps view of a data center from Google. They were like, this is where the data racks are, and it's like a small corner of the entire site, wow. and the rest is just water pumping systems.
Oh my goodness,
to pump the heat out.
Yeah, that's just so real. But yeah, I think to the question about why Apple took the advantage.
Where's that water going to come from?
Yeah, the advantage isn't magic, right? It's been there for us since the 90s. It's just how seriously do we take efficiency? And Apple, to their credit, when they decided to switch to ARM and to, lighter weight GPU technology.
Importantly, again, because Intel MacBooks were underperforming in executives' hands, and the executives sat there, looked at their MacBooks and said, well, this just isn't sustainable. I can't do this anymore. Like, we can't keep going this route.
So yeah, and now it's paying dividends on the AI, because I think I've seen more and more of my colleagues who are like AI DIY type people, they just want to work happen models and stuff like that. They take the same journey that Osi and I did. Our first experiments with Gen AI back in March, April of 2023 were on Nvidia GPUs, right? And then it's like as soon as Apple Silicon came out, it's like, oh my God, look at that, and the funny thing is MLX came out in December of 2023. And at that point, I think M3 had just been announced or something like that.
Something like that, yeah.
So now we're thinking, hey, M3s just came out. The price of M1s are plummeting, and MLX still works with an M1. So we can get a super cheap M1 with, a decent amount of RAM, decent compute. And, like my laptop that we're talking on, here has 64, gigs of RAM. And, I can run an amazing number of, usually quantized, but the stuff I can do with it just on LM Studio privately never leaves my laptop. It's just mind blowing. It's so awesome.
Yeah, I wanted to give LM Studio a plug here too, that, for anybody interested in starting with local models to really connect to what Uche and Osi are sharing, LM Studio is the fastest way to grab a model from Hugging Face, run it 100% locally, and see that an M2 chip is highly performant for your ability to put in a query. It might not be the fastest inferencing or the fastest response time, but it is adequate to read it, actually deeply understand it. And I think, you also have to think about like what Grok is doing with their, entire stack and their focus on the hardware layer. Like, I really think they're going to be a subversive player in this space over the long run, where like, I mean, their ability to compute on chips that are the same size as an M3 chip or an M2 chip is, magnitudes greater. And so as we see like highly specialized hardware companies like coming out to push the local, local models, cutting out this whole idea of like telemetry, who you're sending your data to. I'm really, really interested what you guys think about DeepSeek. Have you used it in LM Studio at all in that? Like, is it available there yet?
Not DeepSeek. I do think, not the full R1, full fat R1, because to Osi's point, you need a stack of, Mac Studios or Mac Minis to do that. But I've just used the distilled. I have on my laptop used the R1 distilled versions of like Llama and Quen and stuff like that, and they are remarkable. Honestly, I mean, it's worth people out there knowing, okay, it's true. If you use like R1 distilled Quen or Llama, you're not using DeepSeek. Just let's get that straight. Because I've many times heard people saying, yeah, I'm using DeepSeek on, my, home workstation. I'm like, how many GPUs do you have your home workstation? And they're like, oh, it's only, 14 billion parameters. I'm like, no, that's the distilled. But
it's inspired.
But it's worth pointing out that they are completely different models in my observation than they use DeepSeek to distill Quen, which people are local large language model enthusiasts
also
already. Also a Chinese model that people were already saying this thing is so good. And then the DeepSeek distilled version of Quen is like, to me, even a step above that. So DeepSeek R1 is now taking large language models that existed in the past and is turning them into smarter models, I think, in noticeable ways.
And the other thing is that, like, again, like, it's not something you can just go out and do in an afternoon of just installing a basic program and downloading it. But you can go and get the full size model, and you can assemble a couple $1,000s of hardware on your desk, and you could run it if you have the means to do so or the reason.
I think $6,000 price tag was what I saw in one of those photos of somebody.
I don't think anyone has a good reason to do that. I think if I had the means in a second.
We've run into one of the interesting non-engineering aspects of this whole thing. Some people do actually have a genuinely good reason to do this. What if you can't go to an API for your problem? What if you have a sensitive problem that doesn't have, you're not allowed to go out to an API, especially a Chinese API.
Air-gapped. It has to be air-gapped. Yeah, if it has to be air-gapped, then
you have to run a high quality model on the order of, GPT-4 or GPT-01, but on a local machine.
Yeah,
this is.
I would certainly hope if that was your job, you had access to a GPU in whatever.
Oh, that's true. Hopefully they're funding you for that level of isolation.
But I worked with banks a lot, and they legitimately just had computers in the back, like in all.
Right. Yeah, it makes sense. But yeah, I think to your point, the way that the practical way, we should point out the practical way for people out there to experiment with DeepSeek now is through so you find like Perplexity, who hosts DeepSeek R1. Sorry, you can go to DeepSeek R1's app itself, but obviously it's hosted in China, and I hear people freaking out about it. I'm going to set aside some of that political stuff, not because I'm scared of it, but just because we could talk about that for another hour. But just, if you don't want your data, going to China, well, Perplexity is now, at least it's using R1 for its searches. And in my use of Perplexity Pro with R1, it's kind of giving you R1 type of reasoning full on. And it's already much better than Perplexity used to be.
And we used to use Perplexity with like Claude Sonnet, which was already like good. Yeah. It was already great, I should say. You're like, especially compared to modern Google, which is its whole own topic. But yeah, it's the go-to way to go find information on the internet these days. And adding R1 to the back end of that is just fantastic.
Yeah, and Azure is now has full fat R1 available. So there are going to be ways to fully run R1 if you need to. Grok only has the 70 billion parameter sort of the words have become confused. It's not really distilled. It's just a parameter reduced version. But yeah, there are people out there who are going to be hosting it. It's just going to increase because I think DeepSeek technology is out there. Everyone's going to start running it.
Actually,
Right? Yeah,
incidentally,
I think it's just going to push. Like, I feel like it's probably just going to push a lot of projects forward at OpenAI. I mean, like, I feel like even the research assistant they just launched was like the immediate response to DeepSeek. Like, I feel like they're sitting on a lot of stuff, thinking they're at the forefront. And when it comes out,
Newsflash,
just going out tomorrow.
I mean, it's not like that for years, hasn't it?
Yeah.
But I feel like it's only, the speed of engineering takes time ultimately. And, these things that we've seen white papers for, that's like, okay, there's not really that much of a moat here for your open AIs and whatnot are finally coming manifest. We just didn't expect it to come manifest from across the Pacific Ocean.
Right. I also just think betting against open source software, like if you find yourself saying open source software, they'll never be able to do that. It's not a good market position to be in.
Exactly. That's kind of like being in the 70s and like, yeah, I can beat the market. It's like, no, you can't.
But like a very finite amount of time. And then unless you decide to buy all the GPUs in the world, which I think Sam Altman might try to do.
He might very well try to do it. OC has a newsflash though, by the way.
Speaking of Perplexity, it looks like you can actually use the new Gemini 2.0 Flash model on it, which I will be trying that out later today to find out.
Yeah, what is that? That's supposed to be really fast, right? Is that why it's Flash?
It's very fast, but they upgraded it. I want to say 2 days ago, Google announced the new version of Gemini, and Gemini Flash is kind of like their fastest.
Google's back, baby.
Efficient and cheap.
Yeah.
The critical aspect of it that I've seen people who are actually trying to use it mention is that compared to OpenAI, it is literally 95% the price to run, which presumably is because Google doesn't have to pay as much in power, speaking of those data centers to run it. And even compared to R1, which already blew everybody's socks off about 2 weeks ago, it's, I think, about 50% to a quarter the price to run R1. It's not necessarily to exactly the same heights, but a lot of the times you don't need that. And so for those situations, that's going to be great. Being able, especially again, if it's way faster.
Right. Well, I find there's like certain problems where it's like 100 really fast API calls at the same time is just as useful as one really long one to go through certain types of data.
And going back to agents, sometimes that's even more useful.
Yeah.
Sometimes you can get those 100 calls to do a lot more work than that one big API call would have gotten you.
Probably exactly.
Like, you used to be able to run an API call and then dump it all in the prompt, whatever it returned. But now you could even like go piece by piece on the data, run those really fast API calls and give just a summary into there. Or it's like things like that. I think that architectures like that are going to have very specific use cases.
Yeah.
Yeah. The scientific models, I think, are going to be for like more of the, I don't really understand what they're aiming for with the scientific models. Like just like to solve more complex tasks. Like,
yeah, I think so. I really think it is. I really think it's new therapies, new what do you call it? Materials is a big one, because I think invention of new materials is actually the next frontier for humanity. It's like, how do we get in space? How do we protect ourselves from radiation in space? How do we,
one of my dreams is to ride a space elevator, and if we get there because of this DeepSeek model, I'm going to be.
I don't know if it's going to be DeepSeek, but AI will get it. Is going to be.
It will be some sort of metamaterial.
It'll be a metamaterial.
If we ever build a space elevator, and it's looking more and more to Chay's point that we'll be building those with the help of. We'll be constructing those and building those with the help of AI. I mean, another really interesting aspect where metamaterials have a huge potential to change things is the metamaterials that we interact with every single day in silicon processors.
Yeah.
Those are
lithography. Go on.
Those are currently two-dimensional. They are functionally two-dimensional objects, maybe 2.5-dimensional if you're feeling really fancy. They've got a couple of layers and that's where everything happens. What if we just took the same square of silicon and then you took it into 3D?
it's mind blowing, actually. Mind blowing what we could do. I mean, it's like Moore's law. It's kind of like Moore's law, but add another, factorization on top of it.
Literally a whole new dimension.
Add a whole new dimension.
But it comes with a whole lot of challenges especially heat that become way more difficult when, normally chips exist as a chip sitting on top of a substrate, and then there's just a big cooler on the top of it as it stands. And all of a sudden, if you have a 3D object, you can't get to the middle of that to cool it. Unless if you've got a really complex scientific AI model that's able to somehow, for example, route little heat pipes in through that complex mess of computation to get to that core to get it cooled down.
Right. Well, I feel like so much of science, and I mean, to some extent engineering, although it's like a little like less of this, or maybe it's more of this, I don't know. But it's basically just like, okay, I want to know what happens when we do like these 10 things. I'm going to do an experiment. And like, it's literally limited by like how many grad students you can have that will go to programs, right? And like, if you have an AI that performs at like half the level of a grad student, we could go and do the experiments and present the stuff back to you. I mean, you alone, like, that's what I think they mean by science is like literally the basic task. Like, hey, go look through this microscope. It does screenshots great. It can figure out microscopes.
Right.
It's like, hey, this looks off. This looks totally different than we expected. And if it could do entire experiments like that, then people could use it to like amplify their research times thousands.
One of the folks at RMAG, who's always a pleasure to talk to, is a researcher down here at CU who is specifically interested in synthetic data as generated by various AI systems in order to, as exactly as you said, significantly speed up research capabilities by just using data that isn't actually real, which is weird and strange, but it's working really well. It's really fascinating. And it's yet another angle where all this stuff matters and is important beyond just,
right. Well, it's things like, I forget where I heard this or read this, but it's like, it was showing like how much of data is not in AI systems right now, like in terms of training and stuff. It was like astronomy data is like one of the largest data troves on Earth. Like they just have a bunch of freaking pictures of the sky, and like heck yeah, I can't sit down, or no astronomer could sit down and spend their whole life looking through them all.
Yeah,
you can. And
so space and underwater, right? It's all patterns. There's so many areas of patterns. So. And I know that we've gone for a bit, but I mean, I think the kind of the theme today just has really been because, to take it back even a step, we started out by talking about January. I don't know if anyone remembers, and that's amongst us, but also amongst anyone watching this, how I believe it was in December that everyone was saying, oh, we're going to hit a wall here in Gen AI. Wow, we're going to hit a wall in Gen AI. Well, that was like a massive topic of discussion. And I'm like, what? We haven't even started engineering yet. This is all science. It's all science.
We're still using, I mean, to bring it back to the discussion earlier, we're still using general purpose computers to do this task.
Exactly. Yeah, if it's getting cheaper, then we're not hitting a wall in my mind. Like honestly, in the wall of like capability, like the fact that it's not taking over the world is really freaking convenient.
Yeah. I like it. That's a good way to put it.
Like, but I'm glad to hit a wall there. That was fine for now. I don't need AI right now. I need to build out these systems.
Right? But it was literally 1 month later. It's like we're hitting a wall, and literally 1 month later, DeepSeek comes out. It's just crazy. And to Eli's point earlier, I really do admire Grok as well because they're one of the few companies legitimately saying we are engineering, we're bringing new techniques from top to bottom, in how do we, make this better? How do we take it from the lab and make it, proper? How do we make it practical for the real world? Grok is one of the early companies doing it. And I think you're right, Eli. They still probably have some aces up their sleeves, which will unfold, and it'll be really interesting to watch that space.
Absolutely. So if you guys were to leave like our audience with one kind of takeaway, from our discussion, what do you think is the call to action for folks listening? What's important about these agentic workflows and the affordability and efficiency of these models, right?
Yeah, for me, I think it's we've been like the AI DIY crew, all the the five of us certainly have been saying for a while that you need to go get your hands dirty, right? You need to
download on Studio.
go down the
And it never has been.
Exactly. We've been saying that, and I could still maybe when we first started AI DIY, well, like 7-8 months ago, I could still see someone say, "It's still a little too hard for me." That's over. I mean, the LM Studio is now so good that the sort of stuff that you can just kind of download and start to experiment with, it's amazing. And then, okay, can you run full DeepSeek, on your little LM Studio rig? Maybe not, but you can experiment with the distills, right? You can, and lower weight versions of DeepSeek will continue to emerge. You can really get your hands dirty,
fine tunes on top of that,
and fine tunes. And so you can start to really say, I am going to play in this space. I'm going to do stuff. I am going to, get my hands dirty, and not just, I'll pay attention to what OpenAI and Perplexity and Meta are doing, but I'm going to try to run my own agent. To Keith's point about, it's better to try to write an agent that does 100 quick tasks than to try to send one massive. I mean, OpenAI operator and cloud computer use and stuff like that is driving me crazy, because I'm like, this is mainframe thinking. Like I don't know if anyone remembers computer mainframes, yes, where it's a big machine in the basement. You submit
I was like, why are we doing this? We could do literally anything else. There doesn't have to be an image of a VM right now. Like, what is this?
Hey, and so let's get away from mainframe thinking. Let's think, how can we break problems into small pieces, and how can we deploy the small pieces that we understand, as opposed to delegating it to a giant out in the cloud to do everything.
Yep. And I was going to say, like, the very same thing, like, that my biggest takeaway is just download LM Studio and play with these things. It's very much like, I don't know, I've been saying a lot that that it seems comparable to like what it must have been like when they harnessed like generating electricity, and then everyone was like, but what are we going to plug in?
Right.
There was a whole group of people that were just coming up with shit that they plugged in. And that's where we're at now, man. I mean, these things, like, the focus in research has been in getting these models to work, but like, while they've been thoroughly tested, I mean, their applications have not been thoroughly tested. And there's just so much opportunity for, like, in technology, for you to sit down on your computer, download LM Studio, and literally just messing around, do something that no one's ever done before, which in and of itself is cool, right? Like, it's a new technology. People are still playing with it. And although it's the most popular one on earth, it's still brand new, and no one really knows where it's headed. It changes all the time.
Yeah, I think my takeaway on that front is that 2025, although yes, it's the year of like AI agents, I think the way I think about it to like lay people or just like the general entrepreneur is that I think this is the year of very affordable, like, micro applications that are very personal and tuned to me. In the past week and a half, I've probably built 10 apps that, do very specific things for me using V0, that just in a series of 10 to 15 prompts, I've got full stack web apps that now do exactly what I need them to. And I really want people to embrace that kind of thinking. But go ahead, OC, sorry.
Similar story with Lovable there. Yeah.
Yeah.
What about you, Chris?
I just say, like, try out all of the models and like, and switch models when they get worse and better. Like Claude had integrated DeepSeek just a few weeks ago, and it was pretty wonky. It was giving some crazy results. So I got into switching, like, trying them all out and just seeing it's interesting, like, the different results they spit out. And
they've got personalities.
Yeah. They're all different. And like, like, Keith's got LM Studio on his computer. He plays around with it all the time. And try that out.
Right? It's like it's either I can't decide if we're in a golden age of development or the beginning of the dark age. I can't tell you.
Right.
But I love it, It's just
right. Yeah. If it's the beginning of the dark age, well, let's develop like crazy until someone shuts off the light.
We're going down
right.
We're going down swinging.
It's probably worth noting that it really, every one of these tools, people have come along and said, this is going to replace you.
Yeah.
And it more and more seems like that and every historian who looked at this was saying, no, that's not how technology ever works.
Yeah. The printing press didn't replace scribes. The Industrial Revolution didn't replace laborers. Yeah.
And it feels like with stuff like LM Studio, like Lovable, Eli, what did you mention? Sorry,
V0.
V0 is pretty good.
V0.
Yeah.
With these tools, we're seeing the capability for people who do have the experience and do have the ability to go that deep into things, and maybe sometimes still don't have to always get their hands dirty doing those things. And don't stop just because you think that these things are going to take over your job, because you're still going to have things to do. We're never going to run out.
I would also say, like, a virtue of being an engineer, someone said this to me early in my career, he said the best part about his career in building software was that he got to work in so many different things while just building software. And so I feel like, don't sleep on the fact that as an engineer, it's like specifically a software engineer, like our ability to reach into different domains, while it's a little stuck up at times, it is a skill that is wildly useful in AI, in terms of like going in there and figuring out what like the core needs are. I mean, that's still like going to be wildly essential to the task.
No, not
Interpret the humans.
as long as people are doing less social engineering, right? And like actual meaningful engineering, like let's take all of those really smart Stanford kids. Let's go task them to work with AI on actual like meaningful work. I think that's
No, man, gotta sell ads, bro.
yeah, some more clicks, Hey, well, thanks a lot, guys, for joining. I know we've been going for about 45 minutes. It's been great to catch up. And always great to hear the stories. Can't say enough good things about Rocky Mountain AI Interest Group and what's going on in Colorado. I think all of our listeners, viewers should really, be tuned in, I know we've got some in San Francisco, New York, Colorado is coming on.
I think our mutual friend Ryan's got something coming up on Thursday.
Oh yeah. Ryan's doing like a builders meetup over in Boulder next Thursday. Yeah. And then I'm doing a tech and design meetup on February 20th downtown at Green Spaces here in Denver. So the community is very alive. And so, looking forward to the next one, guys. Yeah, this was really great.
Yeah, this is great. Always good to talk hardware. Love it.
Always good to talk hardware.
Totally.
All right.
Stop.
Yeah.
Awesome.